So data link control. So this is here is a simple definition for what is data link control. It is responsible for node-to-node communication within the data link layer within. So remember, it is within. Okay. Then within the data link layer of OSI model, it provides services to ensure. So it helps for reliable and efficient communication, just for easy understanding. So you can improve your English is good. You can enhance your sentences in the examination hall between two nodes. See, between adjacent nodes. The primary function of DLC is just you have to mention all the three things which comes under this topic, that is framing, flow control, and error control. So first we will discuss all the three topics in this, but first let us just talk about framing. So framing is process of, see, a simple word. If I have to say you first, so here what you will do, you will break them into pieces and you will have it will be having its own unique source address and destination address. Okay, size may differ and all like that. So just like that, just remember this key definition. See, breaking down the data streams into manageable pieces. These manageable pieces are called frames. Each frame is distinguishable. See, each frame is distinguishable from the others, allowing the receivers to identify the start and end of the each frame. So what? Three things. First, it will break data into manageable pieces frames. Frame are distinguishable. Then why is distinguishable? And because it is distinguishable, it helps for identifying the start and ending of the data. We had studied in the module 1, right, where data communication is packed and like sent to different routes, networks, and will come at the end. Here, just instead of packets, here it is like frames. Purpose, framing frames to distinguish different. So see, purpose that it distinguishes different messages and it adds the necessary control, adds control information in the sense what, source and destination address. Then frame size, fixed frame size and variable frame set size framing. Fixed frame size in the sense what, frame size is fixed here, it won't be changed. So it like ATM says, see, constant size unnecessarily defined, so no need to define boundaries here. But here we define the boundaries here because it is variable size. So it what to say, frame vary in size requiring to define. So here we have to define the boundaries. Approaches are two there, character oriented framing and bit oriented. In character oriented framing, use specific characters as delimiters, both are delimiters. It can lead to issue if the delimiter appears in data. Solved using byte stuffing. Here byte stuffing is, here bit stuffing is. Here bit oriented framing uses bit to delimit frames. Issues of delimiters appearing in the data are solved using bit stuffing. So here specific characters are used as delimiters. It should not be there in data actually, but if it appears in the data, it will be removed by byte stuffing. So I'll just show you that thing here. See here, character on data to be carried at 8-bit from the coding system as ASCII. We leave that all those things. A frame in a character oriented protocol simply is flag, header, at the end trailer, and in the middle you have data from the upper layer. Any data will be there from the upper layer. From that will just go down like that. So by chance, see, data from upper layer is this stuffed. This is one, but here this what is that? Delimiters are here, na? These two things. So that will be removed by unstuffing. Byte stuffing, unstuffed. Same thing you will do with bits over here. See, two extra bits are there here and here. So that will be removed, and that is byte stuffing and unstuffing. So this is all about frames. Then here are the key points. Framing enables clear data separation. Two types, fixed and variable size solutions for the delimiters issues, stuffing and bit stuffing. So conclusion, you can just see here, understanding whatever there. We'll move for flow control and error control now. So here this is the repeated part. So let us start with flow control. Flow control is nothing but it is a mechanism that ensures that the sender does not overwhelm the receiver with data. In the two devices are there, I am sending and you are receiving. So if I am sending to you, I shouldn't send in such a way you will get a headache from the burden, in the sense your load, what to say, to receiving, you cannot receive more because you're still processing the data and you don't have the other additional size to keep the coming data. So what you will do, signal saying that I can't be load, so either I'll wait or I'll transmit the data slowly. It's simply like that. See, sender does not overwhelm the receiver with data. It is essential to maintain a balance. See, remember this key point: maintain a balance between the rate, see, rate at which sender transmits and the rate at which receiver processes it. If data is produced fast, see, if produced faster than being consumed, the receiver become overloaded, leading to data loss. So it's just like filling water in a filled a glass of water. See, there is a glass already filled with water, and there is no space for additional water to come. If you are still pouring the water, what will happen? The loss of water, right? Like it's like that. So the key points of flow control are buffering. So there is a buffer on both sides, yes, in the sender and the receiver. Data can be stored temporarily. So flow control often uses buffers. Array, where is my cursor? So flow control is actually controlling the flow of data itself, right? So it uses buffer for controlling. So flow control uses buffers memory location where data is temporarily stored. There can be two buffers, like I said, receivers and senders. In receiver buffer, it becomes if the buffer is full, it sends a signal to the sending sender to slow down or stop the transmission. Like feedback mechanism is nothing but the flow control can be implemented by sending feedbacks from the receiver to the sender. So the receiver is sending to the sender. For example, if the receiver is overwhelmed, can send signal to sender to pause the transmission. It will notification to slow down, but if still that's actually overwhelming, it will just say to stop the transmission. There are two types, that is stop and wait and sliding window. In stop and wait is nothing but it will send first one frame until the acknowledges and sends back the signal that it is acknowledged. The sender won't send the next frame. I'll just repeat it. The sends a frame, the data to the receiver, or it transmits the data as frames. If the receiver acknowledges, then only the sender will send again the next frame until the signal is not received from the what to say receiver. If the feedback is not received from the receiver, that the frame is not being if it is not sent, then it will again send the frame. Sliding windows are nothing but like your sliding doors in apartments is there, right? At a time one or more than one frame you are sending, at the same time it is acknowledging more than one frame. So before talking about error control, I just forgot to show you this diagram for flow control. Just see producer. So this is a sending node and this is a receiving node. Data link layers both the side. Frames are pushed. Control. Just draw like this and give a diagram is necessary, right? So now we'll talk about error control. Error control is vital to ensure that the data sent over a network is correctly received. In the sense, I'll just send it, but you should receive it properly. For example, if I'm sending you money through this post or something, money order, you have to receive full money. If it is missing, right, it's just a loss, right? Not for me, but for you especially. So when data link layer, okay, so wait, it involves two techniques. Error control involves two techniques, that is error detection and correction. You can see again for easy explanation or understanding. So let us talk about the key points in these key points of error control. Error detection. First, it will detect the error. It won't. It's not necessary. It won't count the errors. It will just detect if error is there. For correction, we need to know the exact number of errors where it is correct. Acknowledging is nothing but once the error is corrected, it will just send an acknowledgement to the what to say to send again or to the receiver like that. If you just read this one, so let us read once. When data is transmitted, link layer adds extra bits such as CRC or checksum to the frame to detect errors during transmission. If the frame arrives is discarded and the sender is informed to retransmit the frame. So error correction, if some protocols error correction mechanisms are used where the receiver can correct errors in the data without needing the sender to retransmit the data, retransmit the entire frame. Forward error correction, that is FEC, an example for. So here it will correct the error and ask it to the receiver to send, and here the receiver itself corrects the data. That this is known as FEC, forward error correction. Acknowledgement when a frame is received without errors, the receiver sends an acknowledgement back to the sender. If no acknowledgement is received, the sender assumes that the frame was not corrupted and pre-transmits it. Very humble and good people. Yeah. Error control techniques, that is CRC and automated repeat request. CRC is what as a cyclic redundancy check that the division vagina you do, right? You just that you can simply give an example also and fill the paper. Automated filling is necessary. You have to underline and your pattern should be good. Then only it carry the weightage of marks. So automatic repeat request, a method that uses acknowledgements and retransmission. If a frame is detected as erroneous or lost, the receiver requests the sender to resend the data, the frame. So it's just like if error happen or lost, it just something happen, it will keep on requesting again and again until it has received correctly. So combination of flow and error, you just read this, it's more than enough. So we have to move to the next topic. So here there is not much thing there in this error control, but I have explained it properly good enough. You can also see first video for this. So we will see you in the next video. We will be talking about combination of flow and error. So don't forget to like and subscribe.